So let's talk about the case now where the base number is not the same. So the first example I'm going to do is 2 to the x power equals 7. So I know that 7 could never be written 2 to some power. So this answer is not going to turn out perfect. Because if it was 2 to some power, I would just set the exponents equal to each other like I did in the last problem. I know I can get a pretty good estimate of what the answer would be because I know that 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. So I know that my answer is going to be somewhere between 2 and 3 because 2 squared is 4 and 2 to the third is 8. In fact, it's going to be closer to 3 than it is to 2. But I want to try to find the exact answer. So let me remind you that earlier we did problems like x plus 4 equals 10. The way that we did this problem was by doing the inverse of adding, which is subtract. If we had a multiplication problem, to solve we did the inverse of multiply, which is divide. So today we're going to talk about the inverse operation of an exponent. Well, we already found in graphing that if we graph an exponent, it looks like this. And if we graph a logarithm, it looks like this. And they are reflections over y equals x. So we know that a logarithm and an exponent are inverse operations. So to solve this one, I'm going to do the inverse operation of an exponent, which is a log. So I'm going to log both sides of this problem. I'm going to have log 2 to the x equals log 7. So now I can use the product property and bring this exponent down and make it a coefficient. So I have x log 2 equals log 7. So now to solve for x, I can divide both sides by log 2. So my answer is x equals log 7 over log 2. Now when we put this in our calculator, we want to make sure that we put a parenthesis around the 7 and the 2. You can do this on either calculator. So I'm going to do log 7 divided by log 2, and my answer is 2.81. And that's what I estimated in the first place. I knew that it was going to be between 2 and 3, but closer to 3 because 7 was close to 8. All right, let's do another problem. So 4 to the x power equals 15. There is no way to get 15 to be 4 to some power. I can get a pretty good idea of what the answer would be because 4 to the first power is 4 and 4 to the second power is 16. So I know it's going to be really close to the number 2. So to move the exponent out of the x out of the exponent spot, I'm going to log both sides. So I'm going to have log 4 to the x equals log 15. Because a log undoes an exponent. So now this x can become the coefficient. So I have x log 4 equals log 15. And then to solve for x, I'm going to divide both sides by log 4. So x equals log 15 divided by log 4. And let's type that in our calculator here. So log of 15 divided by log of 4. And the answer is 1.95. Now in Delta Math, I'm not sure what decimal place they're going to ask you to round to, but you can do that. And we knew this would be close. All right, let's do another example. Example 3. 10 to the x minus 10 equals 9. So I want to solve for x. So the first thing I need to do is get this 10 to the x on a side by itself. So I'm going to start by adding 10 to both sides. So 10 to the x power equals 19. So let's think about this one. 10 to the 0 power is 1. 10 to the first power is 10. 10 to the second power is 100. So that's way too much. So I know it's going to be closer to 1 than it is to 2. So to move the x out of the exponent spot, I'm going to log both sides. And then I'm going to move the x to the front as the coefficient. And then I'm going to divide by both sides by log 10. So I get x equals, and then on my calculator, I'm going to do log of 19 divided by log of 10. Log of 19, oops, I don't need a parenthesis, they already had one there. And I would practice on this on your calculator, and I knew it would be a lot closer to 1 than it would be to 2, and it is. The answer is 1.28. So here's the next example. This would be example number 4. 7 times 9 to the x equals 21. So before I can solve this, I need to get the 9 to the x part by itself. So I'm going to divide both sides by 7. So I have 9 to the x equals 21 divided by 7, which is 3. So I want to think about this one a minute. This time, this number, when I take it to the power, is going to get smaller. So what kind of power would this have to be for the number to get smaller? 9 to the first power is 9. 9 to the 0 power is 1. So this one's going to have to be a number between 0 and 1. So I'm going to log both sides. So I'll have x log 9 equals log 3. And then divide both sides by log 9. So I get x equals, and then log 3 divided by log 9, and the answer is 0.5. Let's go back and look at our problem and see if this makes sense. 9 to the 1/2 power equals 3. Is that true? Yeah, it is true, because 1/2 power means the same thing as square root. So you can see how this actually makes pretty good sense.